So today, this is what we're going to be starting with. So it's just a regular present, and woof, woof, woof! Daisy, can we read the
Yeah, it's really cute. Thank you.
little?
Thank you very much.
Okay, now you're going to do something different.
Yep, now we're just going to look at this parent guide real quick. For this one, I'm not going to do a whole lot of it. They give you the examples for you. I'm just going to go over those examples, and then just like the other parent guide, the answers are, well, they didn't print out because I was out of paper, but the answers are attached to the worksheet, so you still have them, but I just ran out of paper, so they're not right here. We are remembering we're looking at y equals a times b to the x. We're looking at being able to use these equations to write functions and to be able to solve problems for some of this stuff. Okay? I'm going to read through example 1 for you so you can kind of help figure it out. There we go. So most homes appreciate in value, but sometimes if it's used as a rental, then it allows the owner to assume it will depreciate in value. Suppose a house that costs $150 or $50,000 is used as a rental property and then depreciates at a rate of 8% per year. So that means it's decreasing. If we think back to what we did last week, we looked at percents as multipliers, right? And we looked at that idea if it's decreasing, not decreasing, decreasing, by 8%. If it's decreasing, I've got 1 minus my percent, so 1 minus 0.08. That means that my multiplier is going to be 0.92. So I found my multiplier for my equation for y equals b to the x, or a times b to the x. It starts off, my starting point is 150,000. So I know that my equation is going to be 150,000 times 0.92 to the x. Okay, and so they say, what is the value of the house after 1 year? Right, so after 1 year, I just have to plug in a 1 and figure it out. Right, so I'm going to have 150,000 times 0.92 to the 1 power, right? And I get $138,000. That's that value of that house after 1 year. After 10 years, I would just have to plug it in. And remember, always do our exponent first. I just have my kind of cheapo calculator right here, so I'm not going to plug this in. But they give us the answer, and then it ends up being approximately $65,158.27, right? So it does go down after time. And then it wants us to write an equation and make a graph. Would this be easy to graph at this point? Probably. You've got some points, you can plug them in, nothing crazy going on there, okay? And then they want to know, when is it going to be worth half as much? Well, we just make a table, right? Make a table and see when that's going to happen. Half of 150 is 75, and at 10, it's already 65. So I know it's going to be somewhere before there. So we could, if you look, they make a table, and it hits that 75 mark somewhere between 8 and 9 years. Okay, so you can kind of plug in more to get a really good answer like what they did, but I would just say between 8 and 9 years would be perfectly fine as an answer for me. I'm not looking for anything that specific. Okay, the next example is we still have to be able to find our multiplier, right? We have to figure out how is this getting from here to here. And so we can look at that table example from a previous worksheet. We can take this one and we can divide it by the one that came before it, right? So 793.8 divided by 793.8 divided by 756, and I get 1.05. I found my multiplier, right? I can double check and make sure it works. So 1.05 times 793.8, and I get my next one. So my multiplier is 1.05. In order to figure out what my 0th one is, right, I have to work backwards. So I'm going to take 756 divided by 1.05, and I get 720. right? So I get my 0th term, I've got my multiplier, I've got y equals 720 times 1.05 to the x. Okay? You can write that equation out. Another one is dealing with savings accounts, right? Savings accounts are something that show up quite a bit because exponential growth is how compound interest works. And compound interest is how a lot of savings accounts work. So they don't really give us the formula here, which is really kind of obnoxious. So I'm actually going to give it to you. So the equation that we use in terms of a saving account is A is equal to P times 1 plus R divided by N to the NT. R is my rate, T is the number of years, and N is the number of times compounded per year. And then P is the initial money that was invested. Okay, so if you want, push pause, get this in your notes. So if I'm dealing with compound interest, okay, you need to pay attention. You're going to pull it off there, okay? You need to just take your headphones off if you're going to move around, okay? Thank you. Sorry, compound interest. So Luann has $500, and she's going to have a couple of options, all right? The first option is she has 7% compounded monthly. That means 12 times per year, okay? And the other one is 7.25 compounded quarterly, which is only 4 times per year. Okay? So these are the two different situations that Luann's got, and she's going to leave her money in there for 10 years. And we want to know which is going to be the better bet. So looking back up here, for my first situation, right? So for my first situation, my amount invested is $500. My rate is 7%. It's going to be divided by 12. And then I'm going to have 12 times 10, okay? So I'm going to have, for number 1, I'm going to have 500 times 1 plus 0.07 divided by 12 times 12 to the, or 12 times 10, okay? And this is just something, you just have to plug it into a calculator. That's it. You end up getting, after 10 years, that she'll have approximately $1,004.43. That's the first situation. The second situation is very similar, except for she's going to have a slightly higher interest rate, so 0.0725, but it's only going to compound 4 times per year, which means it's not going to happen 120 times. It's only going to happen 40 times over those 10 years. And if you plug this into a calculator, you get $1,025.69. So in this case, the second situation is going to be the one that gives her more money. That's not always the case. Sometimes the ones that just compound more often are the better. It just depends on what that interest rate is. Okay? The next thing, oh, actually that's it. Yep, that's it. So if you look at these, all that you're doing is you've got interest rates, you've got interest rates again, it's depreciating, you know, it's losing. This one isn't necessarily interest rates, but it's, you know, decreasing by 15% each year. So you've got a percent multiplier. For these, you can use your table to figure out what your exponential equation is. You've got a rebound ratio, that's your multiplier, and this is your height. So then you're going to see how it bounces as time goes on. Here you've got information you can write your equations from, and so on. Remember, you've got access to the answers of these. Let me know if you need anything. Have a wonderful day. Adios.